proposing to come up with a new methodology using the drones, deep learning, and photogrammetry. So here's a very short introduction to all the three parts. So the drones are very small and inexpensive, drones, and they are slowly becoming more increasing common, and they are also built from very readily available components, and they use the GPS to control their navigation. And the deep learning is a process in artificial intelligence widely used to classify the images. And the reason why we are using deep learning is because the deep learning method, it will outperform any existing artificial intelligence technology. And the photogrammetry is a technology to build a 3D model from a lot of small photos captured from so many different points. And we are actually going to use all three of these technology in order to detect the crack and to produce a 3D computerized result. So yeah, so the current methodology we came up with has its pros and cons. So the pros are we can actually use a drone for autonomous navigation, and it's safe for the human workers, and we can actually fly to the places where we cannot actually reach. However, for our cons, yeah, there are always a mismatch between the planned flight paths and the real path from the drones. And currently, the main cons is that the drones have a very limited battery life, so that in case if you want to use these drones, you have to carry out the thing for a couple of times. Yeah, and also you need to be a licensed operator in order to have the drones. So this is our system architecture. So the thing is, we will be using the WeBoss open source simulator, and the drone we will be using the DJI Mavic 2, and we train an open source deep learning neural network using a public dataset for cracks, and we actually carry out a proof of concept according to this plan. So let me share you a short video to see how it actually works. So currently we have our drones, and it will fly autonomously, and then it will actually capture the pictures of the building within its flight path. And then afterwards, once it has done the capture images, all the images are being reconstructed using photogrammetry, and so that you have those point clouds, and actually finally the 3D model of that building would be produced. And once we have the 3D model, we will take that 3D texture and we will feed it into our deep learning program, and then that deep learning program will actually detect where the cracks are, and then we will take those texture and we will stick them back to the and we will be sticking that texture back to the 3D model of the building, so that you will see where the cracks are. Yeah, so that's basically the thing. Yeah, and for our simulation, we did with one high-rise building and one wall. Yeah, so and here are our crack detection results on a building and on the wall. So how good is our algorithm? So currently we trying to determine the success of our program by using this criteria. We define the total number of cracks on the building texture and the total number of cracks correctly detected, whether partly or fully. and we defined a success percentage as a proportion of that. And we found that our program was able to detect 100% of the cracks on the building and about just 80% of the cracks on the walls. Yeah. And currently, the program has 2 adjustable parameters, which is a tile resolution, which is the smallest crack which can be detected, and the confidence interval, which is the cut-off threshold. And the consequences of using the high and low tile resolution and confidence intervals are shown here. So you cannot really go high or low, or else you will not get the most ideal results. Yeah. So currently, yeah, we are currently we have already released our code on GitHub, so you can actually scan the QR code or you can read our papers, and we have that link there. And currently, we have done this study, and the whole purpose of the story, to wrap up, is to propose a low-cost and accessible methodology to actually identify the cracks on the wall using the things which you can actually get from the drone, from the consumer drones and the free software. And we are currently trying to do the new research by carrying out this thing in the real world. And we will be writing a new program so that we can actually get the details of the cracks, such as the crack length and the type of cracks and the cost to repair the cracks. Yeah, and thank you very much for listening. If there's any question, I'm happy to answer. I'm Prieto from Smart Construction Group from NYU Abu Dhabi.
Thank you very much, Heiko, for the excellent presentation.